In this tutorial, we're going to briefly discuss collisions. Remember from class that there are two kinds of collisions. Inelastic collisions means the two objects stick together. At the end of the problem, situation, scenario, whatever we want to call it, that means that you're going to have one object that has the combined mass of both objects, meaning you just add up the masses. An elastic collision means that the two objects bounce apart. That means you're left with two objects at the end. So let's look at two examples together from your assignment packet. On page 7, let's first of all look at question number 1. You're told that two cars are traveling in opposite directions on a highway when they collide head-on. You're given the mass and velocity of each of them. The important thing is that you're told that they stick together after the collision. So remember, your first step is to draw a before and after picture. Your before picture might look something like this. Your after picture might look like this. Again, you're told they stick together, so that means that you're dealing with an inelastic collision. You're asked at the end of the problem to figure out the velocity of the two cars after they collide. Well, since they're stuck together, they're going to have the same velocity. Step 1 is to figure out what the total momentum of the system is. To do that, we're just going to find the momentum of each object individually and add them up. So the momentum is mass times velocity. So for the first car, you just multiply the mass of 1200 by the velocity of 35 meters per second, and that gives you 42,000 kilogram meter per second. Do the same thing for the second one. Just multiply the mass by the velocity. Second car's mass is 1,400 kilograms. The second car's velocity is negative 28. You have to recognize that since the second car is going to the south, it's moving in the opposite direction as the first one, so you have to recognize to make that momentum negative. So that gives you a momentum of negative 39,200 kilogram meter per second. So now that you have the momentum of each individual object, just add them up to figure out the total. Remember that the second one has a negative momentum. So when you add those two together, you get 2,800 kilogram meter per second. Since this is collision, you know that the momentum of the system is going to be conserved. That means the total before has to equal the total afterwards. So since the momentum is conserved, the total momentum after the collision is 2,800 kilogram meter per second. That's the thing that we have to remember remains constant. Since we have just one object now, we know what the mass of that one object is. Simply add up the masses of the two vehicles. So together they have a mass of 2,600 kilograms. So all I have to do is take the momentum of the one object, which is 2,800, divide it by the mass of that one object, which is 2,600. And when you do that, you get something like 1.1 meter per second. So the thing to remember when doing this is that they stick together. You have one mass and one momentum. So just divide the momentum by the mass to get your answer. Let's look at an elastic or bouncy collision. So flip to page 8 and let's look at question number 5 together. In number 5, you're told you have an 800 kilogram train car moving on a level track at 16 meters per second. It then collides with a second car of mass 1,600 kilograms, which is traveling in the same direction at 4 meters per second. Upon impact, the first car slows to 10 meters per second. So this is an elastic collision. The two objects bounce apart. Our first move is still the same. We're going to start out by drawing a before and after picture. So you're told the first train car's got a mass of 800 kilograms, traveling at 16 meters per second. So it starts out looking like that. The second train car is moving at 4 meters per second in the same direction and has a mass of 1,600 kilograms. So both train cars are going to the right. The blue one's just traveling faster, so it catches up to the second one, the red one. Our next step is to figure out the momentum of both the objects before they run into each other. So just do mass times velocity for each of them. Note that since they're both going in the same direction, both of them are going to have a positive momentum. So when you do mass times velocity for each of the cars individually, the first one's got a momentum of 12,800 kilogram meter per second. The second one's got a momentum of 6,400 kilogram meter per second. And then find the total just by adding those two up. So your total would be the 1280 plus the 6,400. So that gives you a total momentum of 19,200 kilogram meter per second. Our after picture, we have the first car moving still forward at 10 meters per second. So you're just told that it slows down. And our job is to figure out the velocity of the second car. So our after picture looks something like that. Trying to figure out the velocity of the second car. Momentum is still being conserved, so we're going to draw that arrow again, indicating that momentum is conserved. So that means my total momentum after they collide is still 19,200. So since I know what the total has to be, and I can figure out the momentum of one object, then I can figure out the momentum of the second object. So our next step is to figure out the momentum of the first car after the collision. So I'm going to use the original mass of 800 and the new velocity of 10 meters per second. So when you do that, you get a new momentum for the first car of 8,000 kilogram meters per second. The total has to be 19,200. So I'm going to set 19,200 equal to 8,000 plus the momentum of the second car. After they collide. So when you add the 8,000 to both sides, that gives you 11,200 kilogram meters per second equals the momentum of the second car after the collision. Our last step, now that we know the momentum of the second car, is to figure out its velocity. So velocity is momentum divided by mass. So take the 11,200 kilogram meter per second divided by the mass is 1,600. So that means that the new velocity of the second car is 7 meters per second. So things to remember in an elastic collision, they're going to separate so you don't have the same object. Or one object, you have two objects that are still moving independently of each other. But momentum is still conserved. So the key thing to remember is that the total momentum before and the total momentum after are still the same. Hopefully this tutorial helped you out a little bit. You should be able to work all the rest of the problems on pages 7 and 8 now. Remember that the answers are on this website so that if you need to check them, you can. If you have questions, come see me during tutorial times. Be happy to help you out.